expected value and fair price. Expected value is what we expect to happen over the long run. It's not the outcome of one single event. And you'll see as we go through examples today that what we calculate for expected value is something that, well, that couldn't possibly happen if you only did this once. That's true in a lot of cases. But what expected value tells us is if you did this thing over and over and over and over again, over the long run, this is what we would expect to happen. Sort of a mean long range outcome is what expected value is. And you'll see that when we do examples. When we look at the different situations we're going to explore expected value through, each event will have different results, different things that could possibly happen. And each one of those results will have a probability associated with it. So that's what we're going to look for is results and the probabilities that go with them. This entire day is driven by this formula right here that gives us expected value. We're going to use this formula over and over and over again in a bunch of different situations. The idea behind this formula is this, that when we look at some sort of event, there's going to be results, and we find the first result and the probability that goes with it. We're going to multiply those together, and then we're going to do the exact same thing with the second result and the probability that goes with it. We're going to multiply those all the way till we get to the last result and the probability that goes with it, and we're going to multiply those together. And then after we've done all that multiplying, the last thing we're going to do is we're going to add these results together, and that's what's going to give us our expected value. So let's just put this formula to use. I have this spinner. So it's a game that I'm going to play. And I walk up and, there's an arrow on here, and I'm going to flick that arrow, and it's going to go around and around and around and around, and it's going to land somewhere. Wherever it lands, that's what my result is. You can think of this in terms of money because that's a perfectly good way of thinking of this. I could either win $7, or lose $7, win $10, or lose $4. Those are the different things that could possibly happen. So those are my results. The way we're going to approach this when we're looking for, the expected value of this spinner, we're going to go ahead and write down our results. And our possible results here are lose $7, win $10, lose $4. In looking at this spinner, when I see how it's cut up, if I look at this and we're going to assume it's on a flat surface, everything's fair, the spinner moves nicely. The fraction of the spinner that is represented by this piece right here, that goes back to the area model from Math 122, that's awesome. But the fraction of this spinner represented by that piece right there will give us the probability that my spin lands there. So since it's the one that I highlighted, what's the probability that my spinner is going to land in that chunk of my circle? And again, it's just what fraction of the circle is given to plus 10. Perfect, Nadine, Jennifer, you're exactly right. So what I'm saying here is the probability that I win $10 is 1/4. 1/4 of the time I'm going to win $10. And you can see on the spinner there, the same thing's true of that lose $7. And then there's something else you might notice here, that if I look at lose $4 down here at the bottom, that's half of the circle. And while it's perfectly fine to write it as 1/2, what you're going to find is that expected value formula works so much nicer when each one of these fractions has the same denominator. So rather than look for a common denominator later on, I'm going to go ahead and do that now. And instead of calling that 1/2, I'm just going to say that it's 2/4. Let me know if you have any questions on that. You might be a little skeptical, like, why do they need the common denominator? That's a perfectly reasonable question that I will clear up for you. But if I just want to make sure you're good with the probabilities here being 1/4, 1/4, and 2/4. If we're good with that, we'll go ahead and take a look at using that formula. All right. So the formula for expected value is the probability of event number one multiplied by whatever that result is, whatever result number one is, plus probability of result number two multiplied by whatever result number two is. And then we just keep going and we do this with all of them. So that's how we're going to set up our formula here to find the expected value. So my expected value here is going to be, let's see, probability number one times result number one, 1/4 times -7, plus, okay, probability number two times result number two, 1/4 times +10. And then finally, probability of the last one times the event, the result of the last one. So we're going to have 2/4 times -4. Before I go forward, I want to give you a chance to ask any questions you have about how I plug that in and give you another way to think about it. Some people really like a formula and just kind of following the formula to the letter. That's great. If you're comfortable with that, perfect. An alternative you have to think about this one is 1/4 of the time, the player is going to lose $7. 1/4 of the time, the player is going to win $10. And 2/4 of the time, the player is going to lose $4. If you want to think of it in those terms, that's great. That might help you plug into the formula more easily than just kind of looking at the formula itself. Now all we need to do is simplify, and we'll have our expected value. All right, well, multiplication comes before adding. That's order of operations. I'm going to rewrite this as a fraction so that I'm multiplying fraction times fraction. That's how we multiply fractions by whole numbers, but just to make sure, we'll go ahead and rewrite it that way. All right, so my expected value here then is, let's see, multiply numerators, 1 times -7, multiply denominators, 4 times 1. 1 times 10, 4 times 1, 2 times -4. The negatives are really important. Don't forget about those negatives. -8, 4 times 1 is 4. Right here, we get to the point in the problem where, boy, am I glad I have a common denominator. Otherwise, this fraction would have 2 in the denominator, and I would have to get a common denominator at this point. In my opinion, you're allowed to disagree. It's easier to get a common denominator over here than it is when you've already started simplifying. So my suggestion is to go ahead and get the common denominator when you write the probabilities down instead of waiting until you're already in the simplifying process. Now we just need to add these together. We have fractions with a common denominator, so that's going to stay the same, and then we'll add -7 plus 10 minus 8. When I start getting into positives and negatives, I could do it in my head, but I kind of feel better. Go ahead and use my calculator. I'm allowed to. -7 plus 10 minus 8, that's -5. I have -5/4. Expected value questions, we're going to write those answers in the form of a decimal. So we're going to go ahead and divide this. -5 divided by 4 is -1.25. That's going to be our expected value here. What this expected value means, the negative tells us that the player is going to lose $1.25 per spin. When I first talked about expected value, I said it's over the long run, not what happens on one single event. So if you're looking at this thinking, well, wait, I thought the only possibilities here were lose 7, win 10, or lose 4. How in the world will they lose $1.25? On one spin, they won't. What happens is over the course of 100 spins or 1,000 spins or 5,000 spins, they're going to lose $1.25 per spin. Sometimes they're going to win, sometimes they're going to lose, but over the long run, they're going to lose $1.25 per spin. Expected value is how Las Vegas works. Casinos know some people are going to walk up there and win. But over the long run, thousands of plays all day long, they know what's going to happen over the long run. Any questions on this before I have you try one? All right, here goes. I want you to find the expected value of that spinner. I'll set up a poll for you. And just as a reminder, you're going to set up a little table with your results and your probabilities. Once you have your results and your probabilities, then you're going to use the formula for expected value to set up an equation that you can simplify and have your expected value. And this is the most basic expected value type of question you can expect to see. We're going to look at the same idea in a bunch of different scenarios, but this is sort of as straightforward as it gets. We've got results, probabilities, expected value formula. Let's go another 15 seconds and then we'll talk about this one. All right. Not unanimous, but strong agreement. That's usually a good place to be. If you have any questions as we talk through this, make sure you ask about it. All right. So what we're going to need to do here is figure out our results and the probabilities that go with them. Then we'll use the formula for expected value. So first, we'll find our results. Our results here, a player could either win 14, lose 3, or lose 9. And then the probabilities are, probability of winning 14 is 1/4, losing 3 is 1/4, and losing 9, I'm going to go ahead and write as 2/4. You could use 1/2 if you want to, but that means you're going to have to get a common denominator later on. Putting in the formula for expected value, 1/4 of the time they're going to win $14. 1/4 of the time they're going to lose $3, and 2/4 of the time they're going to lose $9. Now we just need to simplify. We'll multiply our fractions together. That's 14 over 4 plus 1 times -3 over 4, 2 times -9 over 4. If you see anything in here that you're unsure of, don't hesitate to ask. Chances are you're not the only one with that question. Now we'll add these together. 14 minus 3 minus 18 is negative 7 over 4. And as a decimal, that's negative $1.75. So over the long run, we would expect a player to lose $1.75 per spin. Can't happen in one spin, but over the long run, they'll lose $1.75 per spin. Let me know if you have questions on that before we look at a different type of expected value question. All right. Expected value with decimals. Whenever you attend a ball game, you only buy one item. The prices and probabilities that you buy certain items are as follows. So a beer costs $12, and the probability that you're going to buy that is 0.25. A hot dog costs $7. The probability is 0.60. Soda costs $6. Probability of you buying that is 0.15. What's the expected value of what you will spend? Remember, probabilities can be written as fractions or as decimals. All probabilities are between 0 and 1. And so here we have our probabilities just written as decimals. Well, that's all right. Our approach is the same. We're going to find our results, and we're going to find the probabilities that go with them. And the results here is I could spend $12 on a beer, and the probability of that is 0.25. I could spend $7 on a hot dog, and that probability is 0.60. I could spend $6 on a soda, and that probability is 0.15. Once I have my results and my probabilities, now I can find expected value. As we do this, make sure you ask questions if you have them. So, probability times result. Probability times result, and then probability times result. Now I just need to simplify, and I'll have the expected value of what over the long run, what I'm going to spend when I attend a ball game. 0.25 times 12, that's 3. 0.6 times 7, 4.2. And then finally, 0.15 times 6 is 0.9. And then just like we did before, we're going to add these together to simplify it. And we end up with 8.1. Since we're talking about money here, it would make sense to go ahead and round it to $8.10. If you put 8.1 on a quiz or an exam, that would be fine. You'd get credit for it. But it is money, so 8.10 might make more sense. So the expected value of what I would spend be $8.10. The way this could be valuable for me is if I know I'm going to go to 5 ball games this year, then I probably better make sure that I have $40 set aside for my concessions. Let me know if you have any questions on that one. Outstanding. Expected value, but now with percents. This isn't going to be a whole lot different than decimals, because as we solve this, the first thing we're going to do is convert those percents into decimals. But just to make sure you're comfortable with seeing percents in a problem like this, Rick is going to invest money into a stock. There's a 28% chance that he makes $1,000, a 58% chance that he loses $300, and a 14% chance that he breaks even. Important to note, if you see breaks even, that just means he didn't make any money, he didn't lose any money, he's right back where he started, so his change is zero, nothing. What's the expected value of Rick's investment? So if you're Rick and you see this information, you want to decide, should I invest in this or not? Sure, there's a really good chance I'm going to lose money, more than half, but what is my expected value? And to find that, we're going to use the same approach that we've used so far. We're going to find the results and the probabilities that go with them. So let's see. He could make $1,000. And that probability, there's a 28% chance. So 28% written as a decimal will be 0.28. So that probability is 0.28. he could lose $300. And that probability is 58%. So written as a decimal, that's 0.58. And there's a chance that he breaks even, which is just 0. You could put a plus or a minus on there. It doesn't really matter. It's just 0. And that's a 14% chance. So 0.14. Now we have our results and our probabilities. So we can find expected value. Probability times result. Probability times result, and probability times result. Let me know if you see anything that you're unsure of, doesn't make sense, you have questions about. We're doing the same process every time. Find the results and the probabilities that go with them. Use those to find the expected value. All right, now we'll multiply. Let's see, 0.28 times 1,000 is 280. 0.58 times negative 300 is going to be a negative 174. And then anything times 0 is just 0. And now I need to add these together. So I've got my negative 174 and my positive 280, and that's 106. So the expected value, it's a positive number. So the expected value of Rick's investment is he will make $106. All right, then. If you're Rick, you're thinking, okay, I don't like this right here, but the expected value here is positive, so this is a good investment. Let me know if you have any questions about that. I kind of think the decimal questions are actually a little bit simpler than the fraction ones, because once we get to the simplifying part, now we're just multiplying decimals instead of multiplying fractions. All right. Sounds like we're doing great. I trust you. All right, here's another one with percents that I'm going to have you help me with a little bit. On 77% of the days, it takes you 25 minutes to get to work. The rest of the time, traffic is awful, and it takes you 45 minutes to get to work. What is the expected value of the time it takes for you to get to work? And we'll round this to the nearest minute. So just like before, as soon as we see expected value in a question, we are going to go with results and probabilities. And here the results are, well, it could take me 25 minutes to get to work, or it could take me 45 minutes to get to work. That's it. Those are the only two choices. Those are the only two results I've got here. All right. And when I go up here and I read through this, I see that 77% of the days is 25 minutes. So that probability is 0.77. But I'm not given the other probability. It's nowhere in there. It just says the rest of the time. So either in percent or decimal form, what do I need down here to be the probability for it taking me 45 minutes to get to work? Careful, Shelby. and either one of you, Shelby or Jennifer, tell me how you got that. And it doesn't have to be, it's totally fine. It's a simple mistake like that can really drive you crazy, because you know how to do the problem and you go through all the work and your answer's not right. And you're like, wait a minute, I know I did this right. And you did, you just, a simple little mistake like that can throw you. Don't let that happen. Go back and kind of double check and say, oh, okay, that's what I did here. Philosophically, I understand the concept. I understand the process. I just got a little derailed with a bad calculation. You're exactly right, Jennifer. Essentially, you could look at this one of two ways. You could look at it, well, 100% is all of the time. If I take away the 77%, that is the rest, that is 25 minutes to get to work, that leaves me with 23% of the time, which as a decimal is going to be 0.23. The other approach, some of you might think of it in terms of, well, it's 77% plus the rest of the time has to make 100%. And so what goes in here has to be 23%. And as a decimal, that's 0.23. Whatever your logic to get there, when you're given something like this where, hey, wait a minute, this problem didn't give me the percent for how long it's going to take, or excuse me, for how often I'm going to be in a 45 minutes to get to work kind of day, then realize that the rest of the time is what would get you to 100. And here, that's 23% or 0.23. All right, now let's go find our expected value. That's going to be 0.77. 77% of the time it takes 25 minutes. 23% of the time it takes 45 minutes. So what's my expected value here? And we'll multiply 0.77 times 25 is 19.25. And then let's see, 0.23 times 45 is 10.35. And then we'll add those together. We now have 29.6. So the expected value of the time it takes me to get to work is 29.6 minutes. Be a little bit careful. We did a lot of work here, but we're told to round to the nearest whole minute. So 29.6 rounded to the nearest whole number. The ones place, I'll look one space to the right, that's 5 or bigger. So we'll round this up to 30 minutes. My expected value for how long it takes me to get to work is 30 minutes. This could be valuable if you were trying to figure out how much time you spent getting to work over the course of a month. Well, you could find the expected value for a day and then multiply that by the number of days that you go to work in a month and have a reasonable number. Any questions on expected value, using the formula, working with decimals, working with percents? All right. Now we're going to change things up a little bit and add in a wrinkle. And that wrinkle is involved with raffles. If you've ever bought a raffle ticket before, whether you win or lose, you don't get the cost of the ticket back. So let's just say, and we're not talking about the problem on the page just yet, but let's just say you're going to buy a raffle ticket and the raffle ticket costs $20 and they have a $1,000 prize. Well, okay, you buy your $20 raffle ticket, and even if you're the winner of the $1,000 prize, they don't give you the $1,000 prize, oh, and here's your $20 back for the cost of the ticket. It doesn't work that way. The $20 that you paid for the ticket, that's gone either way. So even if you win that $1,000 prize, you're not really $1,000 ahead of where you started. You're $980 ahead of where you started. Hopefully that makes sense. If not, you can ask me about it. But that's going to be the key little wrinkle that we've thrown in here for raffles and expected value. Take a look at this. 500 raffle tickets are sold for $2 each. There's a grand prize of $200 and 2 second prizes of $50. What's the expected value for someone who buys one of these raffle tickets? Okay, so let's see here. So what could possibly happen? I guess let me back up one step. This says expected value. So I'm going to look for results and probabilities. Now we'll look at what could possibly happen. Well, I could win the grand prize. That's $200. So I'm going to come out $200 ahead. That's not right. What should go here instead of plus 200? And if you don't know, it's okay. But if you do know, throw it out there for me. Very good. Sunshine, Jennifer, Summer, I hope you're right along with them. You're not going to win $200, even if you win the grand prize. Yes, you get $200, but you paid $2 for the ticket. So you're not $200 ahead. You're $198 ahead. That's going to be the difference when we work with raffles. Okay, there are 2 second prizes that are $50. but I'm not going to be $50 ahead. I'm going to be $48 ahead if I win one of those second prizes. If any of this is unclear, you're not sure of it, please don't hesitate to ask. And then it's really easy when doing a problem like this to strictly just go with what the words on the page are. I totally understand that approach, right? Okay, grand prize 200, but I spent $2, so it's 198. Second prize is 50, but it's not really 50 because I spent $2, so it's plus 48. All right, let's find the probabilities and do expected value. The thing is, we forgot a really important piece here. What's the other thing that could happen to me in this raffle? Excellent, Jennifer, Shelby, you're exactly right. I don't win. I don't win the grand prize. I don't win a second prize. And if I don't win, then the $2 I spent on the ticket is gone. I lose $2 because I paid $2 for the ticket. So those are my three results. I could win 198, I could win 48, or I could lose the $2 I spent on the ticket. Now let's find the probabilities that go with these. So there's a grand prize, and there were 500 tickets sold. Remember, most important thing about probability is successes over outcomes. There's one success, there are 500 outcomes, so the probability that I win is 1 out of 500. Not great, but you never know. Okay, this tells me there are 2 second prizes. So I have 2 chances to win a second prize. 2 successes, 500 outcomes. 2 out of 500 is that probability. Okay, nowhere in here does it tell me the probability that I don't win anything. I need to figure out the probability that goes here. What's that going to be? And if you know it, great. If you don't, that's okay. It's very similar to what we did with the rest of the time in the driving one. Not quite, Shelby, but you're really close. Yeah, Sunshine and Jennifer, you're exactly right. And Shelby, you got it. Yeah, perfect. Right. So essentially what we've got here is there are 500 tickets out there. So I'm starting with 500 tickets. I take away the grand prize and I take away the 2 second prizes, and that leaves me 497 other tickets that they're just going to be losing tickets. And so there are 497 out of 500 tickets that are going to lose. The other way you could think about this is if you want to look at just at the probabilities show us everything that could possibly happen. That means 1 out of 500 plus 2 out of 500 plus whatever this is has to add up to 500 out of 500 to be everything that could happen. And so that's how we can end up with 497 out of 500. Either approach that gets you there to 497 out of 500 for a probability is perfectly fine, whatever's comfortable for you. Let me know if you have any questions about what we've done to get to this point. All right, once we get to this point, we're kind of home free. Our expected value is going to be, well, 1/500th of the time, they're going to win $198. And then 2/500ths of the time, they're going to win $48. And then 497/500ths of the time, they're going to lose $2. Might feel intimidating at first, but this is going to work out fine. We've got a common denominator. It's all going to be great. All right, so to go through here, we rewrite these as fractions so that we're multiplying fractions together. And then when we do that, our expected value, let's see, 1 times 198 over 500 times 1, 2 times 48 over 500 times 1, 497 times 2. I don't trust myself doing that one in my head. 994. Don't forget that negative is really important because that's where they're losing money instead of winning. So that's negative 994 over 500. And now, just like we did before, our expected value is what we get when we add these together. And to add these, we'll keep 500 in our denominator. We'll just need to work with the numerators. And so what we've got there is our 198 plus 96 minus 994, and that's negative 700 over 500. Since it's expected value, we'll write it as a decimal, and that's negative 1.4. Since it's money, we can go ahead and write it as negative $1.40. So the expected value for someone who buys one of these tickets is that they're going to lose $1.40. On the flip side of that, what that means is for whoever is selling these raffle tickets, they expect to profit $1.40 on every ticket. So there's information on both sides here. Are there any questions about anything we did there before I have you try one? All right, there's a lot of pieces in there. So I'll give you some time. Find the expected value for this situation. 100 raffle tickets are sold for $5 each. There's one grand prize of $300 and one grand prize of $75. What is the expected value for someone who buys one of these raffle tickets? I'll make a poll for this and I'll let you try it. I'll be patient on this one because there's a lot to think about with raffles, and those big numbers kind of slow us down just a little. So process is the same. Find your results and your probabilities. Then plug them into the formula for expected value and simplify. Be careful because the fractions are, these aren't fractions we typically work with. We started out working with 1/4, 1/4, 2/4. This is, fractions that we don't see that often, but they work the exact same way. This is a much harder version of an expected value question than we've seen up to this point. So if you have a little trouble with this, that's all right. It's your first time running through it. You'll be able to practice and then work on it before you take the quiz. Let's go another, I don't know, 20 seconds on this. If you need more time, just let me know. Totally fine. We're not in a hurry. Just let me know if you have questions when we go through it. All right, let's see how we did on this one. Not unanimous, but strong agreement. Kind of where we've been most of the day, and that's okay. I do, when we go through it, if it clears everything up for you, that's perfect. But if when we go through it, you're still a little uncertain, make sure you ask questions. It's a really important thing for you to do as far as, I don't really know why that happened. Let's make sure I get that cleared up before I go off and do this on my own when I start working on homework problems and I don't want you to get frustrated then. I'd rather have you be a little frustrated now and let us fix it. All right. What is the expected value for someone who buys one of these tickets? So as soon as we see expected value, we're going results and probabilities. My results here. I could win the grand prize at 300, but because I paid $5 for my ticket, even if I win the grand prize, I'm not 300 ahead, I'm 295 ahead. I could win the second prize of 75, but even if I do, I'm not 75 ahead because I paid $5 for my ticket, I'm $70 ahead. And then please don't forget about the fact that you might not win at all. You could just lose the $5 that you paid for the ticket. Now we need the probabilities that go with these. All right, probability of successes over outcomes. There's one grand prize out of 100 raffle tickets. There's one second prize out of 100 raffle tickets. And so that means if there's 100 tickets altogether and I take away the grand prize and I take away the second prize, that leaves me with 98 other tickets that are just going to be losing tickets. And so the probability that I lose my $5 is 98 out of 100. And now we can go to our expected value formula. If you see anything that you're unsure of, doesn't make sense, why is that number what it is? Make sure you ask. We've got 1/100th is the probability that they'll come out $295 ahead. 1/100th is the probability they'll come out $70 ahead. And 98 out of 100 is the probability of losing $5. And now we'll simplify. Okay, so that's going to be 295 over 100. 1 times 70, 70 over 100. And then 98 times -5. I don't trust myself to do that one in my head. So we'll go ahead and use the calculator for that one. That's -490. Negative is really important there. We don't want to forget about the fact that there's a really good chance they're going to lose money here. So we want that negative. Okay, now we'll add these together. We'll have our 295 plus 70 plus a -490, and we add those together, we get -125 over 100. Don't forget about the denominator there. We're adding the numerators in our head, but we're adding the numerators. Don't forget that the denominator comes along too. -125 over 100, and then we'll divide that and have -$1.25. So the probability that the expected value for somebody who buys one of these raffle tickets is that they're going to lose $1.25. Oh, sure thing, Shelby. Yeah, absolutely. And I'm going to compare it with the last problem. In the last problem, we had 2 second prizes, and so our probability was 2 out of 500. This time, we just have a second prize So there's only one success instead of two. And I'm really glad you brought that up though, Shelby, because I don't want you to think that every one of these is the same. You know, we might have a bunch. No, well, it's a I wouldn't say it's a mistake that happens all the time, but it's an easy mistake to make, right? We kind of get in the habit of, okay, a grand prize and 2 second prizes. And then you just kind of read through this one and you read it as a grand prize and 2 second prizes. So when you're working on problems like this, make sure you're careful to really identify how many prizes there are for each category so that your probabilities turn out to be the thing that they're supposed to be. That's a really good question, Shelby, and I'm glad you brought it up. Anybody have any other questions on raffles? All right. Fair price to pay. What you're going to find here is this is a different way of phrasing an expected value question. A game involves 4 ducks that are on a table. A player wins the amount on the bottom of the duck they choose. One duck has $5 on the bottom. One duck has $9 on the bottom, and 2 of the ducks have $1 on the bottom. What is a fair price to pay to play this game? Now, we haven't seen a question like this before, but what you'll notice here is this question's a little different than anything we've seen so far. This is a game, kind of like our spinners were, or a raffle ticket was, where there's a chance to win and there's a chance to lose. In this one, you're going to win no matter what. You're either going to win 5, win 9, or win 1. The thing is, we don't know how much you have to pay up front to play, and that's what we're looking for. We're looking for a fair price to pay to play this game. Mathematically speaking, what a fair price to pay is the same as the expected value. Because what fair means is the house doesn't have an advantage, the player doesn't have an advantage. Nobody has an advantage here. This is just fair. I don't know how it's going to turn out. So fair price to pay is really, this is a expected value question that's kind of hidden in some different language. But if it says, what is the fair price to pay? Really, what we're calculating here is, what's the expected value of this game? Okay, then, if we're doing that, we need results and probabilities. The results here, well, you could win $5, you could win $9, and you could win $1. Now we need the probabilities that go with these. They're not written into the problem explicitly, but they're in there. There are 4 ducks on the table, so that's our number of outcomes. And one of them has $5 on it, so that probability is 1/4. Let me know if any of these numbers don't make sense or you're not sure of where they came from. One of the ducks has $9, so the probability of that is 1/4. And then 2 of the ducks have $1, so the probability of that is 2 out of 4. Now we can find our expected value here. 1/4 of the time, a player is going to win $5. 1/4 of the time, the player is going to win $9. And 2/4 of the time, the player is going to win $1. We'll simplify just like we've done before. We'll have 5/4 plus 9/4 plus 2/4. We'll add those together and let's see, 5 and 9 is 14, 15, that's 16/4. And we'll divide that and get $4, which you could write as just 4 or $4. What is a fair price to pay to play this game? $4. What that means when we say fair price is what the player is going to receive is exactly the same as what they pay. So there's not going to be any winning and losing over the long run. This is one, if you wanted to just, you wanted to play this with some friends and you don't want anybody to have an advantage. It's just, whatever is going to happen for each player. If they paid you $4 to play and you did this for a few hours, you should break even. That said, if you're a school who's doing a carnival and you're trying to raise money, You don't want to charge $4 to play this game because if you do, you're not going to make anything. You want to charge 5 or 6 or 8 or something more than 4. If you only charge $4 for people to play this game, over the long run, you're not going to make anything. That's what makes it a fair game, is there's no advantage to either side. Let me know if you have questions on that. The key thing to take away from this one is, if you're asked what is a fair price, what you're being asked for is what is the expected value, and it turns into a very comfortable type of problem. Okay, let's talk more about fair games. Remember, for a game to be fair, nobody has an advantage. The house doesn't have an advantage, the player doesn't have an advantage. Something you might play with your friend where it's just whatever happens, happens, but mathematically, nobody has an advantage. A card is selected from the hearts that are in a standard deck. If the card is the ace, the player wins $84. In order for this game to be fair, when the player loses, how much must they lose? Okay, so we haven't seen anything like this before. We are talking about a fair game though, so expected value is going to be in here somewhere. So let's take a look at our results and our probabilities. Okay, results. What could possibly happen here? Well, the player could win $84. And then the other thing is that they could lose. But that's what I'm being asked for. When the player loses, how much must they lose? So how much must they lose down here is the thing that I don't know. That's what I'm going to have to figure out. So I'm going to call it X. All right. It makes me a little uncomfortable, but we'll see where this goes. And okay, they're selected from the hearts that are in the deck. So there are 13 outcomes. And if they get the ace, they win $84. So the probability of them winning is there's only one ace in there. So it's 1 out of 13. Okay, well, that's something. Now I have a question for you. I don't know how much they lose when they lose. That's what I'm trying to figure out. But my question for you then is, what is the probability that they lose? If they get the ace, they win. What's the probability that they lose? Outstanding. Summer, Shelby, Jennifer, Nadine, perfect. And you could think of that two ways. You could say, well, if the probability of them winning is 1 out of 13, then the probability of them losing must be 12 out of 13. Or you can think any of the other 12 cards are losers. So that probability is 12 out of 13. So I've got my results and my probabilities here, and this is a thing about fair games. Remember, a fair game means there's no advantage to the house, there's no advantage to the player. So if you're the player playing this game, or if you're the house playing this game, you don't want there to be a plus or a minus. What's going to happen here, in order for this game to be fair, when we say we want the game to be fair, we're saying we want the expected value to equal 0, meaning there is no winning that's a plus or losing that's a minus. For this to be fair, the expected value has to be 0. Let's see if we can turn this into something we can work with here. My formula for expected value is, well, 1/13 of the time the player is going to win $84, and 12/13 of the time, well, I don't know what that result is. That's what I'm looking for. And at first glance, you might think, well, I'm kind of stuck then because I have two variables in this equation. This is where the idea that the game has to be fair comes into play. Since the game has to be fair, we know the expected value has to be 0, and we can set our equation up as 0 is equal to 1/13 times 84 plus 12/13 times x. Now I have an equation that I can solve. Not something that we do a ton of. A little bit of algebra practice is okay, so that's what we're going to do here. We are going to solve for x, which means we need to get the term with x by itself. So we're going to get rid of everything else on that side of the equation first. Before I start getting rid of anything, though, I think I'm going to go ahead and simplify everything I can and multiply these together. And so we'll have 0 equals 84 over 13 plus 12/13 x. Now I have an equation that's kind of nice and tidy that I can solve. The numbers are ugly and clumsy. That's okay. We'll just be patient and careful when we do them. So let's see. I'm trying to get that x by itself. So I need to subtract 84/13 on the left and the right. On the right, those are going to cancel. And this is going to take me to a place where I have negative 84/13 is equal to 12/13 x. A little bit complicated. Let me know if you see anything that you're not sure where it came from. The numbers are kind of ugly. That makes this look harder than it probably is. But if you have any trouble with the algebra or the numbers, you ask about it. All right, here's one for you. I want to make this 12/13 go away. What am I going to multiply by on both sides? And if you don't remember or you're not sure, that's okay. I just want to give anybody who does remember a chance to tell me. What do we want to multiply by to make that 12/13 go away? I love it. Both it's almost like it's almost like I set you guys up for that. Jennifer with the 13/12 is perfect. That's exactly what we're going to multiply by. And then Sunshine saying the reciprocal. Perfect. Because if you wouldn't have said it, Sunshine, we're gonna multiply by the reciprocal of that 12/13. I'm going to give myself a little room to put it in there. We're going to multiply by the reciprocal. And it's because when I multiply by the reciprocal, everything cancels. So I'm going to multiply by 13/12 on the left and right. This side, everything cancels, leaving the x. On this side, I can cancel those 13s, and I have negative 84 over 12. And at this point, we'll go ahead and divide. Negative 84 divided by 12 is negative 7. The negative there is because the way the question was phrased. The way this question was phrased was, when the player loses, how much must they lose? And so the negative is indicating that they will have to lose. So in this case, they would have to lose $7. Off the top of my head, I don't remember how a question like that will have an answer for a quiz. If you put -7 because they're losing, that would be okay. If it says how much must they lose, I kind of think 7 is really the answer you want to go with there because lose is already implied. So put the positive answer. I'm going to go with that for now. Put it as this, because how much must they lose? You wouldn't ever say in a sentence to somebody they would lose -7. You would just say they would lose 7. And so even though the negative comes up in our answer, when we respond to this, we're going to answer with just the number, because the negative is just letting us know that they lose. So what happens here in the big, and if that's wrong, I'll send out an email to clarify it, because I don't want you to get one wrong because of that. That would be my fault more than yours. What's happening here then is if they get the ace, they win $84. If they get anything else, they lose $7. And if we were to calculate the expected value with these numbers, we would get 0, meaning we have a fair game. Fairly complicated. Do you have questions on this before I have you try one? Awesome. Here goes. A single die is rolled, a 6-sided die. If the result is a 6, the player wins $65. In order for this game to be fair, when the player loses, how much must they lose? I'll set up a poll for this one and let you try it. Remember, we're looking at results and probabilities. Because the game has to be fair, that lets us know our expected value has to be 0. That's going to give us an equation that we can set up and solve. I took a second and looked at my notes, and you won't have a problem with whether you should include the negative or the positive in your answer on the quiz. I'll just say that. It's not something you need to be concerned about. It's going to be very comfortable and simple to figure out what to type. And I'll just leave it there. Let's go another 25 seconds on this one. If you need more time, just tell me. We don't have to be in a rush. Let's see what it looks like. Wow, unanimous on that one. That is awesome. Very good. This is a pretty challenging question as far as expected value questions go, and it involves some algebra. And the fact that that we were unanimous on this one is extremely encouraging. That is just fantastic. All right, I'm going to go ahead and go through it. You let me know if you have any questions as we do. Okay, so in order for this game to be fair, when they lose, how much must they lose? Hey, that fair means expected value is 0. So this is an expected value question. So I have results and probabilities. And the results here is if they win $65. And if they lose, well, that's what I'm trying to find. Single six-sided die. So I have 6 outcomes. If the result is a 6, they win. Well, the probability of that then is 1/6. The probability that they lose is 5 out of 6 because the other 5 things on the dice are losers. Okay, so expected value has to be 0 here, and 1/6 of the time they're going to win 65. And 5/6 of the time, I don't know what's going to happen. That's what I'm trying to find. But I can solve this equation and then I'll have it. So we'll have 0 is equal to 65 over 6 plus 5/6 x. I'm trying to get x by itself. So I want the term with x by itself. So I want to get rid of that 65/6 first. In order to do that, what I'm going to have to do is I'm going to have to subtract 65/6 from the right, subtract 65/6 from the left. These will cancel, and I'll have negative 65/6, kind of an ugly number. Just be patient, be careful, don't be in a hurry, is equal to 5/6 times x. To make 5/6 go away, I'm going to multiply by the reciprocal, which is 6/5 on both sides. On the right, everything cancels, leaving just the x. On the left, those 6's cancel, and that gives me negative 65 over 5 is equal to x. We'll go ahead and divide, and we'll have negative 13 equals x. How much must they lose? They're going to have to lose $13 in order for this to be a fair game. So if they roll a 6 and they win 65, in order to make this fair, if they roll anything else, they're going to have to lose 13. The poll went fantastic. Let me know if you have any questions on that.